Oh, okay. Oh, yeah, by the way, wait, this you leave such a stop why? She already had no chance. Why does she know? Why does she want what do you actually which one? The last couple you might one today? Yeah, today. That's it, that's good. I got a 6. That was a bad paper. It's better than yours. There's completely missed. What's the cube again? Yeah. Write something. She even called you. Right? Okay. Yeah, that's actually easy. You did not find the trash can? No, but then I can actually Yeah, I don't know. Then you should be here. Can we start and then
yeah, we'll just start.
You would have to commercial chest though. Come up by the
okay. I think we first go through the problems from practice 2. So these are from previous AMC tests. Okay, so the first one.
So first one is easy, right? You have a hexagram, which is a regular hexagon, extended on each side a equilateral triangle. Right? Something like this. Okay, so this is a regular hexagon, and they have 6 equilateral triangle extensions. So what's the ratio of the area of the extensions to the area of the original hexagon? So that's about all these 6 rectangles. We add up all these areas, right? You got A1, and then A2 is basically the area of the hexagon. A1 divided by A2. So what's the answer for this one? Just 1 by 1, right? So how do you know it's 1 by 1?
You just like draw the lines inside.
Right, you just draw the lines inside the hexagon, right? So actually in hexagon, if you connect the origin with all these vertices, you also get 6 equilateral triangles, right? Then you can see that actually each one has the same area as the corresponding one outside for the extension. So it turns out that if you add them up, you also get 6 equilateral triangle with the same area. So the area should be 1 by 1, right? That's a very easy problem. The answer is A. Okay, so the next one, you have a, I don't have to draw the picture. So we have an outer equilateral triangle, has an area 16. So the big area, A1, is 16. For the bigger equilateral triangle, and the inner equilateral triangle has area 1, right? So A2 is equal to 1. And then there are 3 trapezoids that are congruent, okay? So then what's the area of one of these? Well, you realize, so what's the answer for that one?
C.
Should be C, right? 5. So it's basically, if you use the bigger one, subtract off the smaller one, then you can see it's only, so the difference would be the 3 trapezoids, right? And then just divide it by 3. So you get the answer 5. Okay? So these are very straightforward. And next one, problem 23. So problem 23 is you have a square ABCD, actually ABCE. And then you have DF. So F is on AE, and D is on EC. Right? So what do you know is you know that AF is 2 times EF, and you know that CD is 2 times DE. Right? Okay. So then if you connect D and F together and connect with B, you get a triangle. Right? Okay. So then you ask about, well, what is the ratio of the area of BFD? So BFD is just this triangle here. So ratio of the area of BFD to the area of to the square ABC. Okay. Okay. So what's the answer for this one?
5 over 18.
5 over 18. Does everyone get the same answer? Okay. So how do you get 5 over 18? Yeah, you only need to tell me like what's the idea, like how to solve this problem.
Complementary triangle.
Complementary, right? It's not counting, but it's still complementary. So basically, you use the whole thing to subtract off 1 triangle, 2 triangles, 3 triangles, right? So you get the triangle in the middle. So whenever something is hard to compute by itself, we try to use complementary, right? We try to count the ones that are easier and then take them off. Okay. So then, because AF is 2 times EF, well, we can just assume AF is 2, EF is 1, right? Okay. So same thing here. We have CD is 2, ED is 1. So we can assume that the square is just 3 by 3, right? So then the total area would be 3 times 3. Then you need to subtract 1 triangle, which is 1/2 times 3 times 2. And this triangle, same thing, right? So minus 1/2 times 3 times 2. And then minus this smaller one, right? Which is 1/2 times 1 times 1. So this one is actually 3 minus 1/2. So it's going to be 5. Yeah, 5 over 2, right? Okay. So then you use 5 over 2, which is the area of this triangle BFD, divided by the whole thing, which is 9. So you get 5 over 18. Right? So the correct answer should be C, right? Okay, so next problem is actually kind of a counting problem, right? It's not exactly a geometry problem, but it's kind of interesting, right? So problem 9. Okay, so we have a square on one side of the equilateral triangle, and on one of the non-adjacent side of the square, we put another regular pentagon, right, as shown, and then we just do this thing on and on, right? So on the non-adjacent side of the pentagon, again, we construct a hexagon, etc., right? So continue to construct the regular polygons in the same way until you construct a octagon, which is 8-sided, right? A regular octagon. Then you ask, well, how many sides does this resulting polygon have? Okay. So we start with a triangle, and then we remove one of the sides, and then put a rectangle here, or square here, right? And then we remove another side here and put a pentagon here. And I remove this side again, right? And put a hexagon. And then I remove another side, and so on, right? So in the end, the result is going to be, I don't know, something like a many side polygon, right?
It's only 8 sides.
It's not good. So you just think about this in your mind, right? So you're asked about how many sides does the resulting polygon have? So anyone have the answer for this one?
23.
There's 23? How do you get 23? I'm sure different people have different ways of counting. But yeah.
So let's do the triangle first.
Okay.
It has 2 sides. Two sides.
So contribute 2 sides for the first triangle, right?
And then like the square, and then so the target
Mm-hmm.
the squares to a hexagon.
Yes. Mm-hmm.
So like the square has 2 sides, that hexagon has 3 sides, and so on.
Yeah. So you basically just count it one by one, right? So and so on. Yeah. So that's a good way to count it. So after add all these numbers, you get 23. Right? Okay. So yeah. So that's one way of counting. That's good. Any other way of counting? Maybe a simpler way to do it. Yeah.
You could draw it out and then do it.
Okay. Yeah, you can just draw it out. For this problem, it works because we only stop at 8. So what if I just continue doing this until I get like a 100 side polygon? Then how do you count?
Oh.
Yes.
So
there's got to be formula we can
first
use.
one
Right?
is 1. The second one is a square from 2 is going to be taken out.
Mm-hmm.
So that's 2, and the third one is 3, and then you do 2 plus 3 plus 4 plus 5, all the way to like 99, and then you add 1 because of the first thing.
Right. Yeah, I see what you're saying. Okay. So I think, yeah, still there are a lot of ways to count. That's actually our next topic, how to count effectively, starting from next week. So for this one, I prefer to count all of the repeating edges together and then take them off at the end. Okay? So to see that what we have in common in between these shapes. Okay. So for example, let's first add all of them together. Suppose these edges, we don't take them off, right? So we have 3 edges for the triangle. We have 4 edges for the square, and 5, 6, etc. Right? 7, 8 until 100. Okay. So I'm adding up all the possible edges together I have. Okay. Now I start to take off. Right. So for example, for the first one, for the triangle, I only take off one side, right? Because that's the only sharing side I'm taking. So basically, I'm taking off this one side. Okay. And what happens for the last one, for the 100 regular polygon? How many sides do we take off? Yes. Also 1, right? Because for the last one, we only have 1 sharing edges between the 100 and 99, right? There's only 1. Yes. So my point is actually the last one and the first one, because they're they're at the boundary, we actually only take up one of the sharing sides. Okay. So, but for any shapes in the middle, actually I'm using two of them. Right? So for example, starting from this one, starting from actually the square, this side is sharing, that side is sharing. So I'm taking out two of them. And same thing here. So this one is shared, and that one is shared. So I'm taking out two of them, etc. Right? Okay. So actually in this problem here, so this problem is easy because we stop at 8. So it's 3 plus 4 plus 5 plus 6 plus 7 plus 8, right? And then we're taking off the sides. You should take off 1 plus, so how many in the middle? 1, 2, 3, 4 in the middle. So 2 plus 2 plus 2 plus 2. And then the last one plus 1. But this pattern actually goes on if you, even if you stop at 1,000 regular pattern, you can still use this kind of pattern. Right? So yes.
What do you have to divide that by 2?
Divided by 2.
No, you thought the contents, so the square count as 2, the triangle also counts that as 1.
Oh, because when I first count, I also double count. Right?
Oh.
So because I'm adding up all the edges together, possible edges, right? So you're right, yeah. If I don't double count at first, then this is counted as double counting, right? So because the edges shared here is also shared in the previous one, right? But since at start I already double counted, right? I've already added all the possible edges together, so that's why I kind of cancel each other. Yeah. But anyways, you can have your own ways to count. So this is just I feel this way is more clear. So as long as you get the right answer, it's okay. So that's number 9. So I think everybody get the right answer. It's 23, right? So let's look at the next one. It's a little bit confusing, but actually it's not that bad. Okay. So number 25 on next page. This is year, I forgot the year. I think it's 2000 or something. So you have a bunch of circles, right? I won't draw them. You can just look at the picture on the paper. So basically you have the smallest one is totally black, right? And that has radius 2. Let's call it R1 equals 2. It's the smallest possible black circle you have, right? And then out of it, you have a white circle. And then that circle actually has radius 4. And every time you add 2 to the radius, right? And then the third one, the black one, is actually has radius 6. Good marker here. Just use that. So R3 equals 6. And then R4 equals, R4 is what? It's another white circle, right? So it's going to be 8. And then another black circle, which has radius 10. And finally, we have the biggest one is a white circle, which has radius 12. Okay, so they're kind of inside each other. So you're asked about, well, what is the approximately what percentage of the design is black, right? So you're adding up all the areas that are black divided by the total area, right? So what's the answer for this one? Yes. So it's A, 42%, right? Okay, so for this one, how do you do this? You just kind of do it step by step, right? Yeah.
So you just like find it and have like the black circle and then you subtract it this white circle.
Yes.
And you keep doing that.
Okay.
And then divide the answer you get when you add all these values by 144 pi.
144 pi is the biggest white circle. It has a total area, which is the circle with radius 12. So you get pi r squared, which is the total area, right? So A6 is actually 144 pi, right? So that's the number we try to divide later on. But then we're trying to pick up all the black parts together, right? So smallest one is just a black circle by itself. So A1 is just pi r squared with r equals 2. So it's just 4 pi, right? So what about A2? So the black part that is between these two white circles. So it's going to be How do you compute that?
36 minus 16.
So it's a big black circle minus the smaller white circle, right? So it's going to be pi. So what is that? 6 squared minus pi 4 squared, right? Which is 20 pi, right? So that will be the second layer, right? And what about the third layer? Third layer, same thing, right? Again,
36.
the bigger black circle, which is pi 10 squared, right? And then minus the smaller white circle, which is pi 8 squared. So you get 36 pi, right? And that's it, right? You just add these three things together. A1 plus A2 plus A3 will be 60 pi, right? 60 pi. A1 plus A2 plus A3, 60 pi. And then divide by the whole thing, right? 144. So you compute this number, you get 42%. Close to 42%. Okay, approximately 42%. Okay. This one is not tricky. It's not hard. You just have to keep a level head and just try to compute, right, the difference between circles and which areas to add up together. All right, so next one we have two circles. So it's a problem 18. Okay, so we have two circles with the same center, has radius 10 and 20. So its radius R1 is 10, R2 is 20, right? Okay, so then, and aardvark, I don't know what the aardvark is, but something is running along the path from starting at the point A. So we start here. Does anyone know what the aardvark is? Maybe just. This word here, A-A-R-B-A-R-K. V-A-R. Animal? Okay, something can. Let's keep it that way. That's ours. Yeah, just Google it. It's just some, might be some movie character. I'm just
it's an animal that digs holes.
All right, so anyways, this is an animal here. It starts at the point A and just go along this path. Just go here and then go to the right and then go down, go up and then go around and then go out, right, to the point K. Okay. So then basically you're asked about, well, how many meters does it run? You're just adding all of them together, right, basically. So then you have, so first of all, you run out 1/4 of the bigger circle. It's going to be 1/4 times 2 pi r2. And then you have, so basically this half and that half will add to 1/2 of the smaller circle. So it's going to be 1/2 of the 2 pi r1. And then there's a diameter of the small circle. So it's plus 2r1. And then finally plus, what else? So these two will piece together to get the difference between R2 and R1, right? So basically, we add a whole bunch of numbers together.
You spelled aardvark wrong. You wrote aardvark.
That should be
It doesn't matter. Actually, it does.
Yeah, anyways, you know how to do this problem, right? So the answer is, what's the answer for this one?
E.
How many get E?
I
Well, I think I also got E. So it's 25 plus 4. All right, so next problem is extremely easy. So it's just 6 by 10 or 3 by 5, right? We're just counting how many squares are. And problem 13 is actually, again, it's like a counting problem, right? It's kind of like a, counting problem. So you have A and B, you have in the Venn diagram, which is what I want to talk about maybe next time. So you have two sets, A and B, basically, right? Okay, so then you know that the union, A union B, has 2007 elements. And the intersection has 1001 elements. And then you ask about what is the number of elements in A. Have you done this kind of problem before?
Oh, yeah.
Okay. So how do you do that in general?
What?
So in general, how do you do this kind of problem? You have two sets.
So you just add 1001 and divide by 2.
Yeah, right. But like in general, you have number of elements in A plus number of elements in B.
Minus the overlap.
Right, a minus overlap, right? Minus the number of elements in A intersect B is equal to the number of A union B. Okay, so in other words, you already know these two, and you know AB has the same number of elements. So then basically you just add them up and divide by 2, right? So 2007 plus 1001 divided by 2, right? So the answer should be C, right? 1504. Okay, and number 14 again is very easy. So the answer is C, 13, right? 14, the answer is C. So number 25, the next problem is so we have a circle is radius 1. So first of all, we have a biggest square here. And then we have an inscribed circle. Okay, and then we have another square inside it, right? Something like this, right? Okay, so now the circle is radius 1, right? So if this is a center point, then this is 1, basically. Right? So then you ask about, well, what fraction is closest to the ratio of the circle's shaded area? So circle's shaded area is this part. Right? All 4 parts actually add together is the circle's shaded area, and then divided by the area between the 2 squares. So the area between the 2 squares is basically the 4 triangles, right? So I'll use a different color here. So between the squares, the area is just going to be these 4 circles. These four triangles. Sorry. So basically, ask about what is the area, the ratio of the red divided by the green. So what's the answer for this one? Anyone get this? Okay, so it's 1/2. How do you know it's 1/2?
Because the answer is pi minus 2 over 2.
Yeah, so how do you get the answer? So pi minus 2 over 2, does everyone get the same answer?
Sort of, you just subtract the smaller square from the circle, and that's like the numerator, and then you subtract the smaller square from the larger square.
Right, so basically, so when this is 1, you know that that's one of the,
Have delayed reaction.
that's one of the special right triangles we have. So 1 1 square root 2. Okay, so then the difference actually between the big triangle and the big rectangle and the small, not rectangle, big square and the small square is given by what? So it's 2 by 2 for the big one, right? And the small one is actually square root 2 by square root 2. Right? So square root 2 times square root 2. So the difference is actually the green part is actually given by 4 minus 2, which is 6. Right? Okay. And then for the circle part is actually the area of the circle minus the area of the square, which is circle is pi r square, right? And then the square again is square root 2 minus square root 2 times square root 2. So it's going to be pi minus 2. Okay, so it's pi minus 2 divided by 2, which is the same thing as pi over 2 minus 1. So it's closest to 1 half.
Even though 1.4.
No, 1.1.
Okay.
Yeah, I was gonna say
Okay, so let's look at next page. Okay, so we have an equilateral triangle. And the regular hexagon have equal parameters. Okay, suppose they have the same parameters. So which means if we know the side of the equilateral triangle is x, the side of the regular hexagon is y, then we know that 3x equals 6y, right? We know they have the same parameter. So if the area of the triangle is 4, now you ask about what is the area of the hexagon. So what is the area in terms of x for an equilateral triangle? Does anyone know the formula? So it's square root 3 over 4 x squared, right? Okay. So this is the area for a equilateral triangle with side x. So what about for a regular hexagon with side y? Is that what happens?
sort of do that thing, except multiply it by 6.
Just do that multiplied by 6, right? Because of the cutoff here. Right? Okay, so it's going to be square root of 3 over 4 y squared divided times 6. Multiplied by 6. Sorry. Okay, so then in other words, what? So the division, I mean the ratio of their area, so the ratio of the area of the triangle divided by the area of the hexagon is given by, so these two will cancel, right? So it's basically just x squared divided by 6y squared. Right?
No, I mean, no, x equals 2y.
Yeah, so then you're plugging x equals, so this is x equals 2y, right? So if you're plugging x equals 2y, you get 4y squared divided by 6y squared. Y squared cancels, you get 2 over 3, right? Okay, so then if area 1 is 4, then the area 2 must be 6. Right? Get the answer 6, which is C. Right? so the next problem, problem 24. We have a circle of radius 2. So we have a circle. Okay, so circle of radius 2 is cut into 4 congruent arcs. Okay, so basically we cut it here, 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 and here. Sorry? Yeah. Right. So then you kind of flip it over, right, and then form this kind of thing. So we have this. Looks like this. Looks like a star, right? So far, 4 arcs are drawn together to form the star figure shown. So what's the ratio of the area of the star to the area of the original circle? So this is area 1. This is area 2. Yeah, go ahead.
Around 4 minus pi to pi.
Okay, so the answer is A. Does everyone agree?
Yes.
So you get 4 minus pi over pi, right? So how do you get that answer? How do you compute the area of this star thing here?
So we draw a square around that one star thing. Yeah.
You draw a square.
Yes.
Looks like this, right?
And then you compute the area of the square minus the area of the quarter circle things.
Okay. So 4 quarter circle things will give you actually just 1 circle, right? Okay. So what about the square? What's the length for the square?
4.
It's going to be 4, right?
The radius is 4.
Yes. The radius equals 2. So 2 plus 2 will be like this is a 4 by 4 rectangle here. Okay. So in other words, area 2 will be the bigger square minus 4 of these smaller quarter circles, right? So if you add up all these 4 areas, what do you have? So if you add up all these 4 areas, what do you have? Just pi r squared, right? Just pi times 2 squared, which is 4 pi. So this is just 16 minus 4 pi is area 2. So the area 1 is just 4 pi, right? So this divided by 4 pi will be 4 minus pi divided by pi. Yeah, cancel out of 4. So simplify it. Okay. So okay, so the next problem is another problem 25. Okay, so we have a square. This area 4 is inscribing a square with area 5. Okay, so we have a bigger square. That's area 5. And then we have a smaller square inscribed inside. Okay, so this has area 4, that has area 5, the big one. Okay, so then you're asked about, well, suppose this is A, that is B, right? So then what is the value of A times B? Okay, what's the answer for this one? 1/2. Okay, so the answer, correct answer should be C, 1/2. How do you get that?
So 5 minus 4 equals 1.
5 minus 4 equals 1. Yeah.
And then 1 divided by 4 equals 1.
Right.
Yeah, and then 1 4 times 2 equals 1.
Right, that's good. So basically, you use the symmetric property of this, right? So basically, this is A, that's B, so that's also AB, that's also AB, and so on, right? So in other words, if you move B over here, it's very clear, right? If you ask about AB, well, AB is just 2 times the area of this triangle here, right? So 2 times the area of the triangle. 2 times the area of the triangle. Okay, so then you have 4 congruent triangles here. When you take off the smaller square from the bigger square, right? So you get 5 minus 4, which is 1. Divided by 4, you get the area of each one of these triangles, and then multiply by 2, right? So you get AB, which is 1/2. All right, next problem is easy again. I just give you the answer directly. So it's B, 750 for problem 20. Okay, so next one, we have 2 semicircles inside a big circle, right? So it's problem 23. It's actually in a coordinate system, right? So I have a coordinate system like this. Okay, so we have PQRS. So P is -1, 1, and Q is 1, 1. R is -1, -1. So they're all symmetric to each other, right? And S is 1, -1. So have a circle like that. Go through these 4 points. Is there a marker in this one? I'm just trying to get a new marker. So it's算没有算。哦，那边有吗？4个总有一个。
烧开水吗？我怎么大一点？咱问我了，我也觉得他那个是很多人的，I mean, it's the best one we have. But I have an idea.
Okay.
Why don't you use the projector and like fill in people's box and just be like,这水行吗？不要带。Oh yeah.
知道行不行？以前我试过，也不行，没有字了，根本就没线了。没线了？怎么这样子？这是给没了，一点都没了。没有了。
它有时候是干的。
Maybe you could call my dad.
我让爸爸送点过来的。
没事，没关系，我就坚持一下。
再点点看，可能过一会儿它就好了。
No, it needs ink. No, it doesn't need water. It needs the ink. Yeah, because I know it could be full of water and all you just water. Yeah, because you're supposed to do like rubbing. Oh, rubbing alcohol. I carry around extra markers and I do it too. I carry around rubbing alcohol. So I carry around alcohol once because
This one's a little bit better. Okay, anyways.
Let's just compare. Do this here.
Okay, so we have these two semicircles pass through the origin O. So okay. Okay, so what's the ratio of the combined area of the two semicircles to the area of a circle O? So this is circle O here.
Because you dip it into the water and
But then you ruin the food coloring.
no, like you're not having it's not like you dip it in the water and you try to write with it until you color water so maybe it'll work.
Yeah, but like nobody cares about food coloring, so we don't care about that.
Okay, so can anyone see the circles here? Okay, so ask about the ratio of the two semicircles here, right? So OPQ and ORS together, right? Then divided by the area of this big circle. Right? Does anyone have the answer for this one? It's 1/2 again, right? Okay, so this is our familiar isometry theorem again, right? So we have 1, 1. So this radius here for the big circle is going to be how many? 2. Square root 2, right? Okay. So then basically you have the area for the bigger circle is going to be pi r square, which is pi square root 2 square. So it's 2 pi. Whereas if you combine these two semicircles, they're the same area. Each one has radius 1, right? So it's going to be it's going to be the whole circle, which is pi r square, pi y square, which is pi, right? So A1 is pi, A2 is 2 pi, so the ratio is 1.
Maybe you could dip that in water, no, like that, like the brush thing, because
Oh, the brush thing?
because it might like it has right ink on it, so maybe you can write with that.
That's really thinking outside of the box.
You can tell I wrote an I.
It's hard working, right?
Bring extra shoes. No, bring extra socks. Look at me carries around socks. Tissue socks. Okay, socks. I'm easier.
I don't know, I thought he was. So do the ink typically work?
This one works for now. Let's hope it works for a few more minutes. Okay. So we have a small circle and two circles with the same center again. Okay, so chord AD is tangent to the inner circle. So this is AD. And then you have the inner circle is centered at the point C. They're both centered at the point C actually. So we have CAD as a triangle. Okay. So CB, of course, is going to be perpendicular to the tangent line. Okay, so now we have, what do we have? We have AC is equal to 10. And the chord AD has length 16, right? So what's the area between these two circles?
64.
You get 64 pi, right? So area between these two circles. So it's basically a Pythagorean theorem again, right? So we have 10 is the area of the radius of the bigger circle, and then the radius of a smaller circle is given by, so this is 16, total is 16, half is 8, that's going to be 6, right? So then it's going to be pi times 10 squared. Pi times 10 squared minus 6 squared, right? So you get 64. Okay. Right. So the next one is a little bit tricky, but if you look at the picture correctly, if you know how to get the area, it's actually quite simple. So what's the answer for number 23?
What?
Yes, six.
Yeah, what's the area of the shaded part shown in the 5 grid?
Yes,
So it's 6, right? Yes, it's complementary counting again, right?
Or you could just connect like the
So which part do we have to take off, basically, from the big square?
just like the other parts.
Right. So what are the other parts?
So there are 4 small squares.
Yeah, so we have 4 white squares, right? They should have the same area. And then we have 4 little rectangles. Medium size. So 4 little square at the corner we need to take off. Okay. So the corner one is easy. So what about the area of the triangle? So how do you find that out?
So on the base is 3 and the height is
Base is 3, so it's 5 times 2, 1 from each side, right? So the height is going to be 2.5, right? So it's 1/2 times 3 times 2.5. We'll give you.
hopefully he stuck it in backwards.
Yeah, it works.
Oh.
Thank you very much.
Stuck it in backwards.
Okay, so as we said, we have 1/2 times 3. That's 3? Yeah, 3 times 2.5. So that's the area of one of the triangles, right? Then you multiply by 4. And then you should add up these 4 corner squares, so we have 4 again. So that's the total area you want to take off, right, from the total 5 by 5. Okay. So compute this number, you should get 6, right? 6 is the right answer. Okay. All right, so next page, problem number 17. So we have 10 unit squares, right? We have 4 in the first row and 6 on the second row. Okay, so the graph looks like this. So we have some 4 other squares on the bottom, like that, and then we have another one here, another one there. Right? So that's on 10 unit squares. 10 unit squares. Okay. Okay, so then this is So this point is P, right? Suppose I'm connecting this point P to some other point Q here on this side. So connect PQ, right? So here we have X and Y for these two vertices. Okay, so what do you know? We know that the portion below PQ is a unit square and a triangle with base 5. So if PQ bisects the area of the octagon, okay, so this is a whole octagon. Right? You fix another one? Thanks. I just need one word. Okay, so we know that PQ bisects.
So everything on top of PQ is divided out below PQ.
Exactly. So the octagon. So everything above PQ has area 5, and everything below PQ has area 5. Okay. So then, what do you know about the ratio XQ divided by QY? So the answer for this one is 2/3. Right? 2/3 is the right answer. So how do you solve this? How do you get XQ and QY?
So you can find QY because the area of P and then that point, and Q is 4.
Q is what do you mean Q is 4?
Like, so this point is like I don't know A,
yeah.
And then so PQ A equals 4.
The area equals 4, right?
Yeah, and then so
because this is 1, right? So on total we have 5, so take that off. Yeah,
and then so PA times QA divided by 2 equals 4, and just solve, and since PA equals 5, we can solve and get Q.
Yes.
A equals 8/5.
8/5, yeah.
Yeah, and then you
Subtract 1, right?
1, and then you get, this is 3/5. And
3/5, that's 2/5. Thank you very much. Okay. Does anyone see how did he get QY? So yeah.
The area formula for triangle. So it's just like it's just
This one's almost done. This one's almost done.
So okay, so we know that all so we know that all of this
Yes.
that's equal to 5.
Yeah.
And if we subtract this,
Yeah.
that's equal to 4.
Yes.
And then so we know that this is 1, 2, 3, 4, 5.
Yes, base is 5.
So then this water. So we go with this and then what I'm getting out. That's more
That's the area divided by
5. So it's 5/8.
Yes.
And then so we
8/5.
and then so this is 5/5, so this is 3/5.
Right. Okay, thank you very much. Yes, so that's why it's 2/3, right? So basically, we only need to identify this triangle here have the area 4, and then you can just solve the height here from Q to A, and then subtract 1, you get YQ, so then you get XQ plus 1. Okay, so this one, the answer is D, right? 2/3. So the next one is also easy, right? You have a square, you have a rectangle, and then you have 2 semicircles on each end, right? So the ratio of AD to DB is 3/2. And you know that AB is 30 inches, so actually get this is 45 and 30.
Well, I mean, it's relatively close. It's relatively, I got it. It's relatively close. I got it left out.
So the answer for number 18 is 6 by pi, right? So the C is the right answer for number 18. And the next one is also easy. The answer is B. Just give you directly. So it's 4.5.
I got something else.
You got something else?
I'm gonna get 0.49.
Okay, so that's 4 points. It doesn't have to be exact, so as long as you get the answer that's close enough. Okay, so last problem. We have two triangles, ABC and ACE. So these two are ABCE. Okay, so we know that AB equals BC. So AB equals BC. These two sides are the same. And then D is the middle point of BC and AE. So D is the middle point of BC and AE. Okay, so it's bisect. AE and BC bisect each other, right? And then you know that CE is 11. CE is 11. So you ask about, well, what is BD? So what's the answer for BD? So that's 11. This is also 11, right?
This 0.5.
And that's 11. So just bisect that, you get 5.5. Right? So very easy. The answer is D. All right. So did you get all the right answers?
Yes.
Very nice. Okay. And for the book, did you finish the readings of the chapter 3 and 4? Right? Okay, so I'll give you the answers for the homework problems. Some of them are very easy. I just give you the answer directly. Others, I want to talk a little bit about it. Okay, so 5.050 on page 196. Yeah, so this one is easier. Just the Pythagorean theorem directly, right? So Bunker rides his bicycle 5 miles south, so 5 miles south here, and then 5 miles west, and then 7 more miles south, right? And then you're asking about how far is he from where he started. So basically you're asking about this line here, right? Then you're gonna form the right triangle like this. So this is gonna be 5 plus 7, which is 12, that is 5. So the hypotenuse is gonna be 13, right? So the answer for 5.050 is 13 miles. So 5.250. This one is a little bit tricky because you have an ant is crawling along the outside of a box, right? Along this line here. So what's the shortest distance that he can walk from A to B? So A is actually the point, the left upmost point, and B is the right corner, right? The right down corner. So what's the shortest pass? Can you think about it? Yeah. How do you get the answer?
So
how do you choose a pass, first of all?
So it says what is the shortest distance he can walk from A and B along the path shown. So like there already gave you a path, and so if you unfold the box, then AB equals 41 because of pi pad.
Okay. Okay. So basically, let me draw the graph really quick. So we have a rectangular box, looks like this. So then this is point A, so that's point B. Okay, so you're given a pass, you're right. So it's gonna be something like this. You're gonna hit this side first and then go on to the point B, right? But actually, you can choose this point. This point you can choose, right? So there's only one shortest path. So how do you know which one is the shortest? So you can also, for example, you can go along this road here, stop here, and here. Right? Yes, they're going to make a line, but they're on different surface. How can they make a line? Yes. So the key is unfold it, right? They're going to unfold this side and put it on the same surface as this side here, right? So I won't draw the picture, but you can think in your mind what happened, right? When you fold it, you kind of break this box, right, and just make a flat plane out of it, right? So if you just fold it, then you're going to see that you're going to connect AB together. So now what triangle would you have? You have AB is going to be the hypotenuse, right? After you unfold it. So what would be the base of the right triangle? After you unfold it, it's going to be this side plus that side, right? So it's going to be, have the length 30 plus 10, which is 40, right? So this base here is going to have length 40. And what about the height? The height is still the same height. It's still this line here, right? So it's going to be 9, right? And after you unfold it, you're gonna form this right triangle. So then you're going to have AB is actually square root of 9 squared plus 40 squared, which is 40. Okay, and then 545. Okay, so 545, you're going to draw a picture like this. So you have a 50-foot ladder go against the wall, right, like this. So this is 50 feet. And then actually the top of the ladder is 48 feet from the ground. So this is 48, right? Okay, and as you start to climb the ladder, it slips. Okay, so then after it slips, you're going to have a different triangle, right? So the triangle is going to look something like this. Okay. All right, and then if the top of the ladder actually drops 8 feet, so in other words, this part is 8 feet, right? Now you ask about how many feet does the bottom of the ladder slide from its original position. So you ask about what is this part, right? After it slide away. So how do you solve this problem? Yes. Yeah, okay. So the first one would be the original one, right? So I have 50, 48. So what's this side here? Yeah, so it's going to be 50 squared minus 48 squared, which is 98 times 2, right? Which is, so what's that? 14, right? Okay. So this one is going to be 14. Okay, that's before the slide, right? And after the slide, we have another triangle, right? So it's going to be, so ladder is still 50, right? So this hypotenuse is still 50, but then this part is going to be 40. So get a 40, 50, 30, right? So after the slide, this whole thing is going to be 30 actually, right? So then 30 minus 14 will give you 60. So just solving theorem 2 times, okay? We'll give you the answer. Okay, so the last one is, again, a cylinder, but it's kind of, the idea is kind of similar to the end problem, right? We're trying to unfold it somehow in order to get the answer. So number 5650. Okay, so we have a cylinder with a 4 cm diameter. Okay, that is 4 centimeters tall. Okay, so we have a cylinder. The base radius is 4, right? Diameter is 4, and then the height is also 4. Okay, so then what's the length of the shortest path from the base to a point at the top of the cylinder on the opposite side? So you're trying to basically move from this side that side, basically, right? So then what you ask about, what is the shortest pass? Yeah, so how do you get the answer?
So
So we unfolded, what happened?
you think we should say
Yeah.
No.
so it's just like the diameter.
Yeah, so the diameter is like one leg and then the height is
Yeah.
another leg. So that like thing, that curve thing will be like
The
hypotenuse.
Hypotenuse again, right? So what's the answer? For this one, what answer did you get? So the height of the, after you unfold it, basically the base is going to be half of the circle, right? And then the height would be the same height, it's just 4, right? But the half circle would be pi, so it's pi d, pi r, I'm sorry, which is pi times d is 4, so it's 4 by 2 is 2, which is 2 pi here, right? So then the hypotenuse would be square root of 4 squared plus 2 pi squared. If you compute that number, you get approximately 7.4, right? Okay, so next one is on page 200. So this is page 200, number 60, right? Okay, so riding a bicycle, you roll over a piece of gum, which sticks to the bottom of your 24-inch diameter tire. Okay. So you roll forward, and this tire makes a 120-degree rotation. And then how high above the ground is the gum on the tire? So I think the key to this problem is try to draw the picture, right? So the picture is actually you have a circle with diameter 24, right? So your gum is actually starting from here, it's going to roll up to some point here, right? So here's your gum. Okay, so then so if you connect this to the center of your wheel of your bicycle, so this angle is actually 120 degrees, right? So then what else do you know? That's it, just 24 inches and 120 degrees, right? So this is going to be 12 inches here. So ask about how high, right? How high above the ground is the gum? So you ask about basically this distance here, right? From the gum to the ground. So it's very natural to break it. How do you break it? You can break it in 2 ways. So you can break it this way, right? So it's going to be 12 plus that part. So this angle is 60 degrees. That's our familiar 30, 60, 90 degree right triangle, right? So this one is just going to be half of the hypotenuse, which is 6, right? So 6 plus 12 would be 18. Right? That's going to be 18 inches off the ground. Right? So next problem, again, it's inside the cube. You don't have this kind of problem very often in AMC 8. Normally, it's just a plane. But some easy ones. For example, this one, if you connect all these diagonals, these vertices, you're going to form a equilateral triangle, right? So these all 3 sides will have the same length, right? If you have, so ask about, so the vertices of a cube of side length 2. So the side length here is 2. So actually, the side length doesn't really matter. But yeah, then you ask about what is area of this triangle, right? So how do you find the area of the triangle? Yeah. Right, just by formula. So I have square root 3 over 4x squared. So you need to figure out x, right? So x is going to be, so you have 2, 2, so that's going to be 2 root 2, right? So you can have this picture in your mind that this is going to be a right triangle, right? So this is going to be square root 3 over 4, 2 square root 2 square. Yeah, times 8, so it's basically 2 square root 3. All right, so next one is you have a regular hexagon, A, B, C, D, E, F. I really like hexagons, right? Because that means a lot of equilateral triangles. Okay, so find the length AC if the parameter is 24. So if the parameter is 24, then each side would be 4, right? So each side is 4, then you know what you want to find out what is AC. How do you get that? You can use law of cosine, right?
No, but like 30, 60, 90 is way easier.
Yeah, that's true. Or you can just draw a right triangle here. Make your life easier.
It's like way easier.
30 degrees. No, that's 30 degrees. I'm sorry. 60 degrees, 30 degrees. So the answer for that one is actually 4 square root 3, right? 4 square root 3. So this is your 30, 60 triangle, right triangle. Okay, so last one, 5.660, you have you have a circle, a triangle, and another circle. Okay, so just draw the picture first. Okay, so something like this, I guess. Okay. So what's the area of the smaller of the two concentric circles? If the side length of the equilateral triangle is 8, so ask about the area of the smaller, right? So the area of this.
So all we need to find is the ratio of the larger to the smaller circle.
Yeah, so this is equilateral triangle, right? So which means, so it has length 8, right? So how do you form the, we know that, we all know it should form similar triangles, right? So how do you form similar triangles here? So here, just draw a perpendicular line here, right? And then draw another perpendicular line there. Right? And that's actually a traditional way of forming the similar triangle. So let's call this A, B, C, D, E, for example, right? So which two triangles are similar? We have the triangle ADE is similar to the triangle ABC. Right? Okay. So then, so basically the radius here DE of the smaller triangle, of the smaller circle, I'm sorry, divided by BC, which you already know, right, is equal to is equal to I'm sorry.
Let me find a relationship of the surface area.
Yeah.
Or just like
Yeah. I mean,
the height of the triangle.
Yeah, or you can use the height of the triangle. I mean, there are a lot of ways to do it. You can base on AC. So what is AC here in an equilateral triangle? So the height of this triangle is equal to, this is 60 degrees, right? 60 degrees, 30 degrees. So we know that AC divided by AB is square root 3 over 2, right? So AB is 8, right? So then we know that AC must be 4 square root 3, right? Okay. So this divided by that is equal to what divided by AC? AE divided by AC. Right? So you can figure out AE and then figure out the smaller circle. Right? So the answer is actually PE is actually square root 3. After you compute this ratio here, to get the area is just pi square root 3 squared, which is 3 pi. Okay, so there are some other circle problems. I'm not sure if I can cover all of them, but do you have any questions? So on page 207, from 5.19 to 5.990, do you have any questions for those problems? So most of them should be pretty straightforward. For the first one, 519, there are a couple ways to do it, right? So actually, you have 3 coordinates. Then you can find out the length, right, for each of the sides A, B, C. So this one gives you really nice coordinates. But just in general, if you have A, B, C's coordinates, each of these points, then you can find the distance. By distance formula, you can find out A, B, A, C, and B, C. And then use the Harris formula, right, to find the area. So everyone know about Harris formula? Okay.
It's like S equals H equals C over 2 and
Yeah, so it's a semi circumference is S, right? So S is basically, so that's A, that's B, that's C. But normally for problems that you can work out using Harris theorem, you can always have alternative ways of doing it. But basically, if you set S to be A plus B plus C over 2, the Harris formula is
S
square root of
S times S minus A times S minus B times 1.
right. So that's a symmetric formula. Basically, it's a pretty beautiful formula, and actually, this one can kind of generalize to quadrilateral case. Yes. So if you have an S minus D, then well, that one has to be cyclic, right? So if we have time, we're gonna probably talk about that, but that's not actually required in this course. You only need to remember Harris formula. And by the way, what are other alternatives of computing an area for a triangle? Yes.
There's like 1/2 AB sine.
Right. You have 1/2 AB sine C is another way of computing the area, right? And then the traditional way is just the base times the height, right? But then based on that, I mean, except for that, you still have these two alternative cases, a method to computing the area. Okay, so let me just give you the answer for these questions. I think you have the answer actually, right, in the book.
Yes.
So you can double check by yourself. I think these are, in general, all pretty straightforward. If you don't have any questions right now. Okay, so that's about it for geometry. I think that's all I want to talk about. So for high dimension geometry, I would say the chance of having a 3-dimensional problem in AMC is pretty slim. So I don't want to spend a lot of time on that because that's really not worth it. And then the similar triangles, I think you It's very important, yes. So I'm gonna assign some homework from the similarity. And I want you to read actually 5.6. That's the last chapter I want you to read through. And then we're gonna talk about some homework problems next time. But mainly from next time, we'll start to talk about counting and probability problems, which is another big section. I'm sorry? Yeah, I haven't decided on the counting split. I'll assign some reading homeworks later on, actually, with your parents, and you're gonna really get it. Okay? So basically, we're gonna start off easy. It's gonna be chapter 2 and 3 combined, right? So it's a lot of stuff we have to cover. Hopefully, 2 classes. But before that, please read through 5.6, which is the last important chapter in geometry. So starting from next week, we'll start counting and probability. Thank you, and I'll see you guys next week.